This is a Wake County Math 2 lesson summary video for the lesson entitled Tools for Solving. In Lesson 4 of Unit 6, Tools for Solving, the purpose of this lesson is to use our mathematical tools and knowledge to solve an inverse variation function or a square root variation function or inequality. An inverse variation equation, remember, is in the form y equals k over x, where k is called our constant of variation. And a square root equation, remember, is in the form y equals the square root of some value. In Lesson 4 of Unit 6, Tools for Solving, recall that we are looking at a square root and an inverse variation function. We are told that a square root and an inverse variation function can be represented with an equation, a graph, a table, or with words describing the relationship. In this task, we're going to be using all of these different strategies, an equation, a graph, a table, or with words to describe a relationship. For each of the problems in this investigation, we were asked to write an inverse or square root variation function or inequality that represents each situation in context. We were asked to create a table that represents the situation and label where the solution to the problem is found in the table. We were also asked to create a graph that represents the situation. And finally, we were asked to write a statement that includes the answer to the problem. So we're going to work through a few of these together as we did in class, starting on number 1. We did use our graphing calculators or Desmos in class in order to come up with the graph or the table. In number 1, we are told that the relationship between distance, rate, and time can be calculated using the formula R equals D divided by T. Recall that this is in the form y equals k over x, so this is an inverse variation function. R, we are told, is the rate or speed, D represents the distance traveled, and T represents the time. If the speed, keep in mind speed was R, of a wave from a tsunami is 150 meters per second, therefore we can plug in 150 in for R, and the distance from the disturbance in the ocean is 35 kilometers. So that would be D. Now be very careful on this. We're given meters and we're given kilometers. So we will have to convert our kilometers to meters. In order to convert our kilometers to meters, we will have to add, in this case, 3 zeros. So this value will become 35,000 over T. We are asked to figure out how long it will take for the wave to reach the shore. Therefore, we need to solve this inverse function for T. From our prior knowledge, we know that we will multiply both sides by T, get 150 times T equals 35,000, and divide both sides by 150 to solve for T. When I divide that in my calculator, I do get that T, or the time, is approximately 233.3. And that is seconds, so I will label my units. So now we've solved algebraically. When I type this function into my calculator, I typed in y equals 35,000 divided by x. If you use Desmos, in this case I use the variable t. As long as you're using a variable, it will be fine. So we're looking for when our y value is approximately 150. So let's look at our table first. If I go down my y's, I notice that the closest to 150 would be here when t is 233.3. So therefore, at 233.3 seconds, we have approximately the speed of 150 meters per second. So looking at the table, that's how we can use our table to find our answer. Using the same thing I plugged into my y1 in my calculator, I then graphed it. So we have one inverse function and one line. So what I actually typed in y1 was the left side of 150, and in y2 I typed in the 35,000 divided by x. So the 150 is in blue, the y equals 150 is the blue horizontal line, and the y equals 35,000 over x is the red inverse function. So we can see that they intersect at this point here, which is approximately 233.3, 150. Moving along to another example where we're asked to solve and we're given the function. Notice now that we're given a radical function. We are told that the speed of a wave during a tsunami can be calculated using this formula. S equals the square root of 9.81 times d, and we are told S represents the speed in meters per second, and d represents the depth of the water in meters where the disturbance, for example the earthquake, takes place. And the 9.81 meters per second squared is the acceleration due to gravity. We are then told that the speed of a wave is 150 meters per second. Therefore, we know we can substitute 150 in where we see S. And we're asked at this point to find the depth of the water where the disturbance takes place. So keep in mind that the depth of the water was our d value. Therefore, we need to solve this radical function for d. Recall that to undo our square root, we will have to square both sides. Therefore, our square root and our square will cancel on the right, and 150 squared will equal 9.81 times d. The inverse of multiplication is division, so we'll divide both sides by 9.81, and d will be approximately whatever we get when we take 150 squared and divide it by 9.81. When we do divide that, we should get approximately 2,293.57. So solving algebraically, that was our answer. Now let's look at what we got when we plugged it into our y equals in our table. So I plugged into my graphing calculator y equals the square root of 9.81x. In Desmos, notice I can plug in a d, but I can't do that on my graphing calculator. So if we're using our graphing calculator, you will want to plug in this radical function in for y1. So in my table, I'm looking for where my y value is approximately 150, because that's what we're looking for in the question. So when the speed of the wave is approximately 150 meters per second, it looks like the closest answer is right here, when x is approximately 2,293.6. So that is the way we can find our answer in our table. In my graphing calculator, I typed in y1 to be 150 and y2 to equal the square root of 9.81x, and I got two graphs. The blue here is the y1, which is y equals 150, and my radical function here is y2, which was the square root of 9.81x. Notice where they intersect is our solution. So the intersection point in our graphing calculator was 2,293.6, 150. That is how we can use our graph in order to also find the solution. The last part of this was to write a statement. So if the speed of the wave is 150 meters per second, the depth of the water where the disturbance takes place is 2,293.6 meters. Okay, so let's look at another question. Let's look at number 5. Number 5 is a little different. In number 5, we're not given the equation and we have to come up with the equation. So let's first make sure we can understand the question. We are told that in kickboxing, it is found that the force, F, needed to break a board varies inversely with the length of the board. Recall that an inverse function is in the form y equals k divided by x, where k is called our constant of variation. Reading that sentence to the left of that word inversely tells us that F is our output, or y value, and that the length of the board is our input, or x value. So I can substitute into the equation to be F equals k divided by L. We are then asked and told that if it takes 5 pounds of pressure to break a board 2 feet long, how many pounds of pressure will break a board that is 6 feet long? So the first thing we need to do is find our k, or constant of variation. So we will plug in 5 pounds of pressure is our force. We will plug in 5 for F. For 5 pounds of pressure, we are told it will break a 2-foot-long board. Therefore, our length is 2, and we need to solve for k. So we'll multiply both sides by 2, and our constant of variation is 10. Therefore, now algebraically, we can answer the question. So we'll plug in, we have F equals 10, and they're asking us when the board is 6 feet long. So F equals 10 divided by 6. Now recall, going back to the question, we are asked how many pounds of pressure will break a board that is 6 feet long. Well, 10/6 is the least amount of pressure needed. Therefore, if we have any pressure greater than or equal to 10/6, that will break the board. Therefore, this is actually an inequality. We can change that equal sign to an inequality sign, knowing that we need at least 10/6 of our pressure, or 1.6 repeating, in order to break a board that's 6 feet long. Let's take a look at how we can see this in our graphing calculator table and/or using Desmos. So in my graphing calculator, or Desmos, you can type in the general rule y equals 10 divided by x. So I can see that to break a 6-foot board, the minimum amount of pressure would need to be 1.6 repeating, which is 10/6. But notice everything greater than that will also break the board, because every amount of force greater than that value will break the board. It is greater than 1.6. When we look at our graph, and we graph in our calculator 10 divided by x, we are looking to see where on the graph our x value is going to produce a y value that's greater than our 1.6. So what we can do in our graphing calculator is type in y1, which is 10 over x, and y2, which is x equals 6, because that's what we're looking for. When x equals 6, we want to know what y is. Well, we can see here that they do intersect at the point 6, 1.6 repeating. But we also notice this highlighted yellow part of the graph will also be able to break the board. Therefore, anything greater than or equal to 1.6 as the force will break the board. So let's write that as a statement. it will take at least 10/6, or we can simplify that to 5/3, 5/3 pounds of pressure to break a 6-foot long board. And let me just make sure that you guys can see that that is indeed 5/3. All right, I'd like to do one more with you all, and that's number 6. To be considered a fuel-efficient vehicle, a car must get more than 30 miles per gallon. Notice the word more than, so we know that we're going to be working with an inequality here. Consider a test run of 200 miles. How many gallons of fuel can a car use on this test run and be considered fuel efficient? In this case, we are dealing with an inverse variation function. We are told that a test run is 200 miles, so the 200 will be our k, or our constant of variation. And we are asked to find, or we are told that a car must get more than 30 miles per gallon. And we are asked how many gallons of fuel can a car use on this test run to be considered fuel efficient. So in this case, we're going to plug in our gallons in for y, and we're needing to solve, our gallons, a car must get more than 30 miles per gallon, and we're asked to solve for how many gallons that would take if the car gets 30 miles per gallon. So we need to solve this for g. Notice again that this is an inverse variation function. So we can solve it just like an equation, but we're going to have to change it to an inequality. So we'll get 30g equals 200, divide both sides by 30, and g is equal to 6.6, repeating. Now recall that it needs to get more than 30. So more than 30 means that this sign will be less than. And you could have had less than for all of these until you got to the end. It is your choice. But make sure you understand that it is an inequality. So now let's take a look at what we typed into Desmos and or a graphing calculator. We did type in y equals 200 over x. And so we're looking to see where our y value is closest to 30. And if we scroll, we notice what's highlighted here. That's the closest to exactly 30. So we see that 6.6 would be an option for us for gallons. But we also notice that everything less than that will also be options for us because g needs to be less than 6.6. Therefore, we have many solutions. If we take a look at how we graph this, we can type in y equals 30, y1 equals 30, and that would be this purple line. And our y2 was the inverse function 200 divided by x. And where they intersect will be our solution. They do intersect at 6.6 repeating, comma 30, but also notice that anything in this highlighted region will also be a solution that's less than 6.6. Therefore, our statement that we can write here is to be considered fuel efficient, a car that travels 200 miles needs to use between 0 and 6.6 repeating gallons of fuel. Throughout this lesson, we solved inverse variation and square root functions or inequalities either by solving algebraically, by graphing, or using a table. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.